This lesson is 11.2, which is called Multiplying Two Fractions. There are two objectives for this lesson. Your first objective is to be able to write and draw multiplication problems by using a model or a graph. Your second objective is to solve multiplication problems with fractions, and some of that objective will be a little bit of repeat from last night's video. So the first objective of this lesson is being able to determine what a graph is talking about when multiplying. And this is brand new, so make sure you watch really closely. On worksheets, you will see that they will put some dots on a chart like this. And so being able to read that, I'm going to notice that the dots are going down a column, and that one out of the 4 columns that exist are being shaded in using dots. So the model right now represents 1/4. Next, I'm going to be shading in a portion of my model, and I might decide to shade in this portion right here. And you can see on my model that looking at my rows this time, 3 out of the 4 rows are shaded. So 3/4 is going to be what I'm multiplying 1/4 by. So just to repeat, looking at my columns going down, I have 1 out of the 4 shaded, and looking across, I have 3 out of my 4 rows shaded. This is my multiplication problem. 1/4 times 3/4. Now, you can already spot what my answer is going to be, because my answer is going to be how many of my squares contain both a dot and shading. And you can see right here in this little area, I have 3 squares that have both a dot and shading that are overlapping. So 3 is going to be my numerator for my answer out of a total of 16 squares. So my answer is 3 out of 16 squares have both a dot and shading. Now let's see if this actually works out well with what we've learned about multiplying. Remember, with multiplying, you just multiply the numerators across the top. 1 times 3 is 3. And then you multiply the denominators across the bottom, 4 times 4. And 4 times 4 is 16. So I know that my chart was done correctly. Okay, we're going to do a second problem. And this time I'm going to hurry and quickly make my chart for you. And then you can go ahead and see if you can understand what this chart is saying. I'm going to go ahead and put some dots going down in these columns. And then I'm going to add in just a little bit of shading. And now I have my problem already completed for me. So the first thing I'm going to look at is how many of my rows, well, actually I'm going to look at my columns. I'm going to look at and see how many of my columns are shaded. My columns are those going down. It really doesn't matter if you're looking at columns or rows first. I just like to be consistent when I'm teaching you. So looking at my columns going down, I have 1, 2 out of 6 total that are filled with dots right now. So that would be 2 out of 6 columns are filled with dots. Next, I'm going to look at my rows going across, and I can see I have 2 of my rows shaded out of a total of 4. So that would be 2 shaded out of 4 possible rows. So this is what my problem looks like. I have 2 6 being multiplied by 2/4. Now my answer is going to be the portion of this model that have both a dot and shading. So I can see that there are 4 squares that contain both shading and a dot. So that's going to be my numerator. And then my denominator is out of the total number of boxes. So if I were to quickly count up my boxes, I can see that this is a 6 by 4. And so a 6 by 4 box is going to have 24. If I were to count each of those boxes individually, you'd find that there'd be 24 boxes, and that 4 of them contain both a shaded square that also has a dot on it. So, checking to see if this actually makes sense with my problem. 2 times 2 across the top equals 4. 6 times 4 across the bottom equals 24. So my model was drawn correctly. Okay, this time I want you to go ahead and see if you can make a model for this problem. Feel free to pause and give it a shot, and then resume this video. So the first thing I like to do is I tend to like to work with rectangles. And if I'm looking at 1/3 being drawn first, I'm going to go ahead and just divide it into 3 pieces. And I'm going to go ahead and just shade one of those. Second thing I'm going to do is look at 2/5. And then I'm going to divide this going down, making sure that there are 5 pieces. And in 2 of those rows, I'm going to put dots. Now, let's see if that actually makes sense. If this were to make sense, I can see that the answer for my problem would be 2, because I have 2 squares that have both a dot and shading out of a total of how many squares I have in my whole graph, which if you were to count these as I am circling them, you'd find that there would be 15 total. So my model for 1/3 times 2/5 equals 2/15. And you can see that because I've done it here down below. Now there's a couple different ways that you can make these models. You could have, instead of shading first like I did, you could have gone ahead and done dots for that. But I find when I'm doing models and drawing them myself, it's a little bit easier to start out with the shading and then finish out with the dots. Now the second half of this lesson is learning how to just multiply fractions straight across. The main thing you want to double check is to see if you are cross-canceling. Remember, cross-canceling is looking at the diagonals and seeing if you can simplify through the diagonals. So I'm going to go ahead and look at this 8 and 4 and see if I can simplify it any, and I can. 4 goes into 8 and it also goes into 4. 8 divided by 4 is 2, so I'm going to stick that number out to the side. And 4 divided by 4 is 1. Next, I'm going to see if I can cross-cancel diagonally the other way, and I can. 3 is a number that goes into both 3 and 9, so I'm going to cross-cancel this 3 and make it a 1, cross-cancel my 9, and make it a 3. Now I can go ahead and multiply straight across, and it's actually rather easy. 1 times 1 is 1, and 2 times 3 is 6. So my answer is going to be 1/6. This problem is fairly different because the last problem should have been just a review. Notice I'm multiplying across 3 numbers this time. So whenever you have a whole number, such as this lovely 4 that's sticking out at the end, go ahead and make it into a fraction. And the way to do that is by putting a line underneath it and giving it a denominator of 1. Okay, so this problem is actually new because there is a different rule when you're working with 3 or more fractions. When you are cross-canceling, you can only cross-cancel one numerator with one denominator. So even though I can see that 2, 6, and 4 all can be divisible by 2, you can only cross-cancel one numerator with one denominator. And that's a pretty important rule. If you forget that rule, your problem will be wrong. So I can see that I can cross-cancel this 2 and this 6 by dividing both the top and the bottom by 2. Now I'm going to check to see if I can take this 3 down below and simplify it with any number up top. And in this case, I really can't. 3 can't go into 5, and 3 also can't go into 4. So I'm going to leave it how it is. I've done all the cross-canceling that I can do within this problem. So next step is to multiply across the top. I'm going to multiply 1 times 5 times 4, which equals 20. And then I will multiply my numerators, 3 times 3, which equals 9. Now, your next step would be to change this number, 29ths, into a mixed number. So, as a review, 9 goes into 20 2 times. 2 times 9 is 18, so that means that I have 2 out of 9 left over in my answer. So, your answer for this problem will be 2 and 2/9. Here is another problem that doesn't contain a whole number, but will focus on learning how to cross-cancel. Remember, you can only cross-cancel one numerator with one denominator. So I'm going to scan this problem and see if any of my numerators and denominators will cross-cancel with each other. One set of numbers that I see is this 9 and 3. I can cross-cancel the 9 and the 3 by dividing both the top and the bottom by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. I am done with that set. Now I'm going to scan and see if there's any other numerators and denominators that I can cross-cancel. And I kind of focus on this 5 and 10. 5 is the number that goes into both 5 and 10. So I can say 5 divided by 5 is 1. 10 divided by 5 is 2. Now I'm going to check my remaining numbers, 8 and 11, and see if they can cross-cancel with each other. There is no number that can go into 8 that also goes into 11, so I have to leave those how they are. Next step you do is just multiply across the top and then multiply across the bottom. 8 times 1 is 8, times 2 is 16. And across the bottom, 3 times 1 is 3, and 3 times 11 is 33. And that's your answer, 16/33. It looks like a very large number. However, we've done all of our simplifying. Can't do much more than what we have already done because we've cross-canceled. So 16/33 is your answer. Practice problem number 1. Draw a model for 2/3 times 1/6. Feel free to pause. This is actually a pretty difficult problem. Here is how I would start going about to solve this answer. Once again, I always enjoy personally shading before I do dots. So I'm going to draw out 2/3, and I'm going to shade 2 of those thirds. Next, I'm going to divide my model into 6 because I have a denominator of 6. So I'm going to make 6 columns drawing down. 6. There we go. And I'm going to be putting dots in one of my rows of 6. So let's see if my model was correct. If my model were correct, the numerator of my answer would be the boxes that contains both dots and shading, which would be 2. And your denominator would be the total number of boxes that we created in the model. So counting these really quickly, this is a 6 by 3 going down. So if I were to count those out, there would be 18 boxes. Now that actually makes sense because 2 times 1 is 2 and 3 times 6 is 18. So I know I drew my model correctly. Does your model have to look like mine? No, you could have done yours in a number of different ways. Another way you could have done it was, let's say I decided to do my rows this way and shade 2 of them going down. And then I wanted to draw out 6 rows going across and put dots on one of my rows. Your model could have also looked like this one, and your answer would still be the same. Practice problem number 2. Pause. Okay, hopefully you decided to put a line under your whole number 3 and put a 1 as a denominator underneath it. That makes it a lot easier. The rest of what you need to do is just cross cancel. So I'm looking for one denominator that can cancel out with one numerator. So these 5s are a good hint to start out, because you can easily go ahead and say, well, 5 divided by 5 is 1, and 5 divided by 5 is 1, so I can cross cancel those out. The next thing, or next step that I need to do is check to see if there are any more places where I can cross cancel. And I can see that my 6 and my 3 have an opportunity for cross canceling. 3 goes into both 6 and 3, so 6 divided by 3 is 2, and 3 divided by 3 is 1. I've done all the cross canceling that I can do. You can't really cross cancel 1s with 1s. They're already in the smallest type of form that they can be. So I'm going to multiply across the top. 1 times 1 times 1 is 1. And then I'm going to multiply across the bottom. 1 times 2 times 1 is 2. So my answer to this really long problem is 1/2, which is why cross-canceling is so much fun. Feel free to draw a smiley face of how well you think you understand, and write a question about today's lesson.